Windows is the result of thousands of engineers collaborating on one of the world's most widely used operating systems. Today, you'll see the curtain on every phase of modern Windows development, showing you how roadmaps become code, builds become images, and insider rings become stable releases.
System architecture and kernel evolution.
With high-level goals in place, architects revisit the heart of Windows, the Windows NT kernel. This hybrid kernel, originally designed in the early 1990s, has grown into a modular engine that neatly separates hardware abstraction, core services, and userland processes. Hardware engineers update the hardware abstraction layer to support the latest chipsets and peripheral standards, while kernel developers refine scheduler logic and memory management routines to squeeze out extra efficiency. Concurrently, security teams embed features like kernel mode code signing, KMCI, and virtualization-based security, ensuring that low-level components remain tamper-resistant.
Designing user experiences.
While the kernel hums along under the hood, user experience designers sketch and prototype every visual and interactive element. They use tools like Figma and proprietary Microsoft Design Studios to iterate on concepts for the Start menu, Action Center, and system settings. These mockups are reviewed in cross-functional workshops where accessibility experts verify color contrast, screen reader compatibility checks are performed, and performance engineers model resource consumption. Once designs are validated, UI engineers translate these blueprints into WinUI controls and XAML templates that will render crisply across laptops, tablets, and desktops.
The code base and programming languages.
The Windows source tree encompasses over 100 million lines of C and C++ code, with targeted assembly for performance-critical routines such as context switching and interrupt handling. Core components like the scheduler, memory manager, and I/O subsystems are predominantly written in modern C++ to leverage object-oriented patterns and compile time safety. User mode services and scripting tools rely on a mix of C#, PowerShell, Python, and TypeScript, enabling rapid iteration for non-performance sensitive portions of the system. All source files live in Azure repos, ensuring traceability and unified collaboration across global engineering teams.
Git workflows and branch management.
Microsoft uses a disciplined Git branching strategy to keep the Windows code base stable and forward-looking. The cornerstone is the main branch, which always reflects the latest production-ready code. Feature teams spin off short-lived branches to implement specific capabilities, whether that's a revamped file explorer or a new security monitoring service. When a feature is complete, a pull request triggers automated style checks, static analysis scans, and peer reviews. Approved changes merge back into main, where they immediately become part of the nightly build and undergo further validation.
Continuous integration and automated testing.
With every merger into main, a sophisticated Azure DevOps pipeline springs into action. The system compiles affected modules using MSVC and Clang tool chains on high-performance build servers. Unit tests for individual drivers, services, and UI components run concurrently, while longer-running integration tests simulate real-world workflows, from launching Office applications to connecting to Bluetooth audio devices. Static analyzers check for memory leaks, race conditions, and security vulnerabilities. Only builds that clear this gauntlet move forward to specialized labs for hardware and performance testing. Before we continue, if you would like to see how other OSs like Android and iOS are made, don't forget to check these videos on the channel.
Hardware lab validation.
At Microsoft's global hardware labs, hundreds of automated rigs and human-operated test benches validate each nightly build against thousands of device configurations. Physical machines cycle through power-on self-tests, sleep/resume sequences, and extended stress runs to catch flaky drivers or compatibility regressions. Networking specialists bombard systems with Wi-Fi and Ethernet traffic, while graphics teams run benchmarks and real-time rendering tests on the latest GPUs. Whenever a model fails, drivers are debugged or rolled back, and hardware partners are notified to update firmware or release certified drivers.
Image construction and packaging.
Once a build is deemed stable, the focus shifts to creating the deliverables you'll actually download. Engineers use the Windows Image Format, WM, and Deployment Image Servicing and Management, DSM, tooling to assemble a pristine base image. This process stitches together the kernel, drivers, runtime libraries, and system apps, then applies compression and encryption. Language packs, OEM customizations, and default applications are injected based on target markets and hardware partners. The result is a final ISO or electronic software download, ESD, package that can be burned to USB, distributed via enterprise channels, or served up on Windows Update.
Insider rings and feedback loops.
Before a public rollout, Microsoft relies on the Windows Insider program to surface real-world feedback. Early adopters join one of 4 rings: Canary, Dev, Beta, or Release Preview, receiving progressively more polished builds. Telemetry and error reports from millions of devices flow back into work items, where triage teams categorize crashes, performance slowdowns, and usability snags. Feature teams review this data daily, fixing show-stopping bugs and adjusting behaviors based on how people actually use the OS.
General availability and ongoing servicing.
When the launch day dawns, the finalized build is flagged for general availability and published through Windows Update. Enterprises can defer deployment or manage it via Windows Server Update services, while consumers simply click download. But the work doesn't stop there. A team dedicated to servicing churns out monthly cumulative updates, Patch Tuesday, and out-of-band patches for critical vulnerabilities. Telemetry dashboards track installation success rates, rollback incidents, and feature usage metrics, feeding insights back into the next planning cycle. From the earliest brainstorming sessions to the final bits arriving on your device, building Windows is a meticulously orchestrated symphony of planning, coding, testing, and collaboration. Every milestone, whether it's passing an automated test or a successful compliance run in the hardware lab, brings us one step closer to delivering an operating system that powers billions of people around the globe. If you found this enlightening, don't forget to like, subscribe, and hit the bell icon for more behind-the-scenes tech explorations.